All right, so we're going to review how to deal with rational expressions. That is fractions that contain polynomials in the top and the bottom of the fraction. Okay, so there's several different techniques. The overarching one is simplifying. And when we simplify a rational expression, we factor everything in sight and then cancel terms that are in common on top and bottom. But we have to be very careful when we do this. The warning is that you can only cancel terms that are multiplied by everything else. You cannot cancel a term that is added to everything else. So for instance, in this example we're going to do, x squared here and x squared here cannot cancel because they are added or subtracted to all of the other pieces. Instead, what we'll do is first we will factor this, factor both the top and the bottom, and then we notice that there is a term in common on top and bottom, the x minus 2, and that we can cancel, leaving a simplified fraction. All right, so the general rule is going to be in everything that we do after this, we are going to factor and cancel everything and simplify after every step, essentially. So we're going to start with multiplication because it's actually the easiest operation. For multiplication, the rule is that basically you just ignore the multiplication sign and glue the fractions together, okay? In other words, it's like this times this all over one fraction, that times that, and now I'm just in a simplified problem. Okay, so I will factor everything in sight and cancel as much as I possibly can. In this case, that is the x plus 2's on top and bottom. Notice I still have one x plus 2 remaining on the top because I'd only canceled one of them and there were originally two. Okay. All right, so division is very similar. We immediately change it to a multiplication problem by multiplying by the reciprocal instead of dividing. Okay, so I keep the first fraction the same, change the division to a multiplication, and flip the second fraction. All right, now in this case, I can once again factor out when I glue them together with multiplication and cancel. Now again, we're going to be careful of how many terms we cancel. 1x plus 4 on top will cancel with 1 on bottom, leaving 1 behind. 1x minus 4 on bottom will cancel with 1 on top, leaving 1 behind, to give us our final answer. All right, now we're going to move to addition and subtraction, which is actually significantly harder. And the reason is you can only add and subtract fractions if they have a common denominator. So first we will force a common denominator, and then we'll be able to add the numerators. Now, this provides another warning, okay? The only time you FOIL in a rational expression problem is when adding or subtracting. And even then, we only FOIL the numerator, never the denominator. Which makes sense. I keep on saying we're always wanting to simplify, right? Simplifying is factoring. So why would I FOIL and undo my factoring? All right, so the first thing I'm going to do here is factor everything in sight to see what's going on. In that case, it really is just factoring this denominator in the middle term. All right, so then a common denominator must be that denominator of the middle term, x plus 2 times x minus 2. Okay. The middle term has both terms. The first term is missing the x plus 2, so I force it by multiplying on top and bottom. The last term is missing the x minus 2, so I force it by multiplying on top and bottom. Notice this also means we kind of have to add some parentheses, okay, to make sure everything will distribute correctly. So my denominator okay, is going to be x plus 2, x minus 2. My numerator, okay, is this plus that minus that. And this is when we're allowed to FOIL. So FOILing out the first term, x plus 2 times x minus 1, okay, gives me x squared plus x minus 2. Plus the x minus 2 minus, FOILing out the last piece gives me x squared minus x minus 2. And I put those parentheses there so that I could worry about the FOILing without having to worry about distributing the minus sign. Now, of course, I'm going to combine like terms, which is made easier when lots of things cancel. And I end up with 3x minus 6 on top. And then, of course, I can factor out a 3 there. And then I notice that one of my factors actually cancels. So my final answer here is a very simplified expression. I'm going to show you one more thing that will come up with rational expressions, as that is simplifying what I call complex fractions. That is, fractions that have other fractions inside them. And there is a trick here, and the trick here is to multiply the top and bottom of the big fraction, okay, that is the one with this fraction bar, by the common denominator of the little fractions, that is the ones inside it. So I look at those little fractions and their common denominator is x squared. So I will multiply the top and bottom of the big fraction by x squared over x squared. Now, on top, I will distribute it to both terms. On bottom, I will distribute it to both terms. 1 times x squared plus, now when I multiply 2 over x times x squared, okay, well, one of those x's cancel and leaves just 2x. And voila, no little fractions left. Same thing on the bottom, distribute my x squared. 4 over x squared times x squared, the x squareds cancel, leaving just a minus 4. All right, then it's just once again a simplified problem. So I factor and cancel and have my result.